This is the second video in a chapter about essential ideas of chemistry. And in this video, we're going to talk about chemistry terminology that you'll need to use. So we mentioned in the definition of chemistry that chemistry is about matter. And matter is anything that has mass and takes up space. So almost anything you can think of. And there are different types of matter. So we're going to introduce some terminology for those different types of matter and sort of a flow chart here. So one quality of matter is whether it is uniform throughout. So it can be uniform or it can be not uniform. If it's uniform, we call it a homogeneous substance. Probably heard this before in a physical chemistry class, maybe in your high school chemistry. And if it's not uniform throughout, we call it a heterogeneous mixture. Okay, so a heterogeneous mixture, heterogeneous meaning multiple different parts, and mixture meaning they're mixed together. An example of this would be a salad. So if you and the folks in your breakout room all stick your fork into the same salad and you each pull out a forkful, each of those forkfuls is going to have a different composition. It's going to be a mixture of different amounts of vegetables. One of them might be all salad, all lettuce, one of them might be all tomatoes, one of them might have a little bit of both. But that salad is not an evenly mixed mixture. So we call it a heterogeneous mixture. So our other option, if it is uniform throughout, it's called a homogeneous substance. And there are several types of those, depending on how many components there are. Whether that substance that's uniform throughout is made up of one thing or multiple things. So if that homogeneous substance is made up of just one component, it's going to be called a pure substance. And if it's made up of multiple components, it's going to be called a homogeneous mixture. So those are important terminologies as well. So an example of a homogeneous mixture would be a beaker of salt water. If you and everyone in your breakout group each took a measuring spoon and took a scoop out of a bucket of salt water, the composition of each of those scoops would be exactly the same. It would be homogeneous. As opposed to the salad, which was a heterogeneous mixture, each scoop would be slightly different. For a homogeneous mixture, each scoop would be the same. But it's the same containing multiple components. A pure substance only contains one component. We have even more terminology to talk about pure substances because that's a big focus of chemistry, as you might have guessed. And what we want to know about those pure substances is, can it be broken down by a chemical change? Chemical change being something like combusting it or heating it until it changes into a different compound. Okay, so if it cannot be broken down by chemical change, that means it's going to be called an element. And you can probably think of lots of examples of elements since there's an entire periodic table of them. One example that I can think of is carbon. Elemental carbon cannot be broken down any further, no matter what you do to carbon, whether you heat it or you combust it or you cool it, it's going to remain carbon. And the smallest unit of an element is called an atom. So you can get down as small as one individual atom of carbon. Let's go back to this side of the fork. So if you have a pure substance and you can break it down into something that's fundamentally different through a chemical change, then we're going to call that a compound. And the smallest unit of a compound is going to be a molecule. So one example of a compound could be ethanol. So ethanol contains the element carbon. It also contains the element oxygen and the element hydrogen. So compounds are made up of multiple elements. And so molecules are made of multiple atoms. An atom is the smallest unit of an element, and there are several elements in a compound, and those atoms of those elements together make up a molecule. So a molecule is multiple atoms bonded together. So these terms here, matter, heterogeneous mixture, homogeneous substance, pure substance, homogeneous mixture, element, compound, atom, and molecule. These are the terminology terms you're going to want to use in this course. And so now let's talk about where we're going to be going in this course. So the way we're running chemistry this quarter is called an atoms first approach. So we're starting from the very, very smallest scale here, an individual atom, then we'll move slightly bigger to molecules, which contain multiple atoms, and then we'll move back to the macroscopic scale and look at how those large amounts of matter behave together. So we're going to use this graphic to keep track of where we've been this quarter. So we're actually going to start from the inside and move towards the outside. So we'll start with atoms at the beginning of the course, and we'll start at the bottom and we'll talk about the parts of an atom and about the different elements. Then we'll look at the quantization of energy and electron configuration and periodic trends to understand how the different elements are similar and different to each other. Then we'll move a little bit larger. We'll talk about molecules which have multiple atoms. We'll talk about how those atoms bond together, how we name those different molecules of those compounds, the Lewis structures and the geometry for how those atoms connect together, and the energies of individual molecules. And then at the end of the course, we'll take a step larger. We'll look at the macroscopic scale, many, many, many molecules at the same time. And we'll talk about concentration units of molarity, and we'll talk about chemical equations and how to balance them, what the reaction types are, and how to calculate a limiting reagent. So atoms first, starting with atoms, moving to molecules, and then moving to compounds.